All right. Hi, everyone. Welcome to Always Coding, our weekly Hacky Hour. I'm Komal Devjani, a developer advocate with alwaysAI, and I'm joined today by Todd Gleed again. He is our model product manager. So welcome again, Todd.
Thank you.
Yeah. And for those of you who have attended Hacky Hour in the past, welcome back. If you're new to Hacky Hour, just so you know, Hacky Hours are designed for our developer community to ask questions about always AI or computer vision in general. So this is your opportunity to pick our brains and ask any questions or share something you're working on. Before we get started, so just so you know, today's topic is gesture recognition and how to build a gesture recognition app from scratch. So from training all the way to building an application. But before I hand it over to Todd to take over, I do have a couple of announcements. So let me share my screen. Just a moment. So we are actually launching our model training challenge. Hopefully you can all see this. And the idea is we want to see what you come up with our model training toolkit. So you can train your own gesture model using your own signs and build an application using your own sign model. So this could be programming your light switch to turn off every time you flip the peace sign. And once you've built your application, you could be anything, be as creative as you like. Tag us on Facebook, LinkedIn, and Twitter at alwaysAI with your project's GitHub URL. We're on all of the social media channels, or you could just post it on Discord or email me directly with your GitHub URL. And if we like what we see, you will be featured on our blog, our LinkedIn. You get a LinkedIn shout out and an opportunity to come and speak at one of the Hacky Hours. And finally, we will provide extra support to all challenge participants on Discord. So if you're interested and you want to learn more, we're here to help you out. So model training challenge, and I'll announce this towards the end as well. So with that out of the way, let's get started. I want to show you how to get started with alwaysAI with a simple hand recognition model. So to get started, you want to go to alwaysai.co and navigate onto your dashboard. If you haven't signed up already, make sure to sign up for the platform. And from here, what you can do is that, on our dashboard, we have our sample project that you can start out, some of our popular starter apps, and most importantly, instructions to download the CLI. This is going to be the most important part of getting started with alwaysAI. So what you want to do is click Install CLI, pick your operating system, Mac, Windows, or Linux. I'm obviously using a Mac, so we're just going to hit Next. And then you want to download this for Mac OS. Once you do that, you can start a new project. But the project that I want to show you, I've already created it. So this is the hand detector from last week. So let's go into hand detection, and I'm going to pull up my terminal. And let's just make this a little bit bigger. I'm going to navigate into my directory for demos. And I want to just configure this project using this command line and hit paste. And just so you know, I've already added the hand detection model. You can really simply add in your model onto any project just by navigating onto our model catalog, selecting the model you want, and adding it to the catalog, to the project, actually. And then once that's done, you want to just do AAI app install, and then AAI app start. Should get started in a couple minutes or a couple seconds. And you want to copy this streamer URL, open a new browser window, and hit paste and enter. And let's see. And as you can see, it can detect my hands. So using this model, right, and our training feature, you can do peace sign, thumbs up, thumbs down, anything you want for your challenge. So now I'm going to hand it over to Todd to kind of take us through the next piece of the gesture recognition app. Todd?
Thank you, Komal. Hi, everyone. How you doing? Thanks for joining us again. What I'm going to go over today is, first, I'm going to recap what we did last time quickly, just for those who might not be there, and set the stage for today, and that is data collection and annotation, and then continue today with training the model, run through how to do that, the commands, both in the CLI and in the Jupyter Notebook version of that. And then I'm going to hand it off to Lila, who took the model that I created and demonstrated last time and built an app around that to control any of your voice activated assistants, Siri, Google, that kind of thing. And she's going to go over adding your data to my model and starting training and that sort of thing. So let me get started. So let me share my screen here. So if you remember last time, the first thing that we went over was data collection. We have a great data collection app that Lila has developed, and she continues to improve upon this. So this is run the same way that Komal just showed, running an object detection app. But what we're able to do with this application is capture images from wherever you're running the application. So from your edge device, and like I showed last time, we captured hands here. If you notice, there's some different styling here, and this new button that I'll let Lila go over a little later. But what you end up with, either capturing images or capturing videos, is the first part of a data set, and that is your data. So let me go here. Let me stop that just to not have that running in the background. But what you end up there with in this samples folder of the image capture dashboard is the data that you just collected. And from that, you upload it into CVAT. I went over a couple ways of doing some pre-processing using Ffmpeg and sampling the videos, or you can upload images directly, but you upload that into CVAT by running the AI annotate command from your terminal, and you get the CVAT, and this is where you annotate, draw bounding boxes around every frame that contains the object that you want to detect. So I have a couple ones for thumbs up and different hand signs here. You see that I kind of did them in a couple different tasks and then combined them together to train. So what you end up with after exporting this from CVAT is a zip file. This zip file, let me just go over just to be clear. Export as a data set and export it as a Pascal VOC 1.1 data set. You can do this from the task menu, or you can do it from inside a task here. But if you do the export as data set in Pascal VOC, that'll export it directly into a format that we can ingest into our model training tool. So you're going to end up with a zip file. I've renamed the zip file the hand signs 3. That's because it has 3 hand signs. And what you'll find in there is annotations, and these are the XML files. You'll have one XML file associated with each of your images. So I've got 645 images and associated annotations, and we put this data set in this current form on our website, so you can download that and use this as the base for your model. It's got 3 hand signs. This I'm calling 5, F-I-V-E, all lowercase. This is peace, P-E-A-C-E, and then thumbs up with thumbs _up. Remember, no spaces in your name. So that's available for you to download. This is kind of showing you the contents, but what you really want is the data set in a zip form, and that you can use that directly from CVAT without renaming it, but sometimes I like to rename it to something that's a little more usable. So that's where we left off. We have our data set, we have it annotated, and we're ready to train the model. So let me show you how to do that. So from your terminal, all you need to do is understand where this zip file is. It could be in your downloads folder. I kind of store things in my datasets folder, and then you can run this command from anywhere, but it's easiest to kind of run it from the folder. That reduces the number of directories that you have to sort through to get to it. And the command is, I'm going to show you using our Jupyter notebook first, and then go over how to do this with just a CLI command. So the command is AI dataset train, and then what it's looking for now is the path to the data set. So we saw that I had signs, I had the initial one, and I have 3. I unzipped it. So here we got the zip version. And then for this, the command is just Jupyter, letting them know that we want to run the Jupyter version. While this spins up, are there any questions about the review from last time, or anything so far?
I don't see any questions yet, but if anyone has questions, feel free to use the Q&A button below or the chat window, or just raise your hand and I can unmute you.
Okay, so what this does is it's spun up a server on the machine that you're working on, and it gives you ways to access that. So this is a Jupyter Lab notebook that is now running, and so I connect to the URL to open it in my browser. Double click the notebook here, the IPy notebook file, and run all cells. This is going to bring up the configuration where we can configure this training session. So I'm going to demonstrate. So these aren't necessarily the configurations that I ran to build my model. I'm going to do it so that it finishes, that we can see, but the premise is the same. So just so it finishes, I'm going to do maybe 200 steps here. When we're training a model, you've got to think of the number of images and how many times you want to step through each one of those images to have a working model. Now, this is not, it doesn't need to be an exact science, because you can always continue from a previous version where you don't lose any of the training from the first time. So, you can do a sample set like I'm doing here with just a small number to make sure that the model is improving. And I'll show you how you can make sure that's happening. So for labels, these are the labels that I mentioned. We've got 3 for this data set. And if you add your own data with your own hand sign, this is where you'd enter it in. If you use mine as a base, include these labels in addition to any label that you may add. So we've got 3 labels, peace, 5, and thumbs up. Next, what it's asking us is the train fraction. And this is kind of, if you've done research, it's the train validation ratio. So what the model training toolkit does in the background is it separates all your data into 2 different groups. One is the training group, and that is where it is going to make guesses, get feedback, and update the weights of the model based on the feedback it gets from your ground truth, which is the bounding boxes. And then the other section is the validation, and it's not going to change the weight based on these images. It's going to apply the model to these images, get some feedback back on how well it does, and then relay that feedback to you to tell you how well the model is progressing. So those are kind of take the place of new images that you would put your model to recognize after it's finished. So common, you want to stay around 70% for train or higher. You could do 75. I'm going to do 80 just for fun, but you can play with that a little, but I'd stay around the default of 70 or maybe up to 80%. And this is the, again, the ratio that is the training images. Batch size, this is going to depend on your computer processing capabilities. We found for just a CPU, batch size of 4 is pretty good. It's pretty standard. To ensure a little more speed, is you can do a batch size of 1 or 2. For demonstration, I might do a batch size of 1. But what this means is how many images is it going to analyze per step, and then it's going to update the weights after each step. So it's going to look at one image, it's going to update the weights, and it's going to do that 200 times. So at a batch size of 1 of 200 steps, it's going to go over 200 images. If you up your batch size to 4, it's going to look at 4 images, update the weights, and then go to the next step. So total, it's going to look at, for 200 steps, batch size 4, it's going to look at 800 images and have that response there. And traditionally, kind of the standard for this is something called Epochs, and that is going through each image in the data set one time. So you see the data set had about 650 images. So a good rule of thumb is going over each one of those, 40, 60, 80 times. So to calculate that number of epochs, you do batch size times number of steps, and then divide that by the number of images to get the number of epochs. So if this was batch size 3, 600 images, steps 200, that's 1 epoch, and extrapolate from there. But usually you want to at least start out with at least 20 and see where that takes you. But realistically, I can tell you for the data set that I use for the demo, for the model that I have, I used a GPU with the batch size of 16 and got, I think, 20,000 steps. So it was a good number of epochs. Here in Model ID, this is the first part of this is your alwaysAI username. And then the second part is the name of your model. So where you find the username is if you go to alwaysAI, you're logged in, you go to your profile, and here is your username. So this is where you find that, and then when the model is finished and you upload it using the same model ID, you can find it in your models. That's on your dashboard, and these are your personal models that you have finished. So we put our model ID. This plot loss is for the graph that's going to come up once we start training, and this is how often to plot the loss. It depends on how many steps, how often you want to see this. If you're just doing 200 steps, you can plot the loss every step or every 2 steps. But if you're doing something like 20,000 steps or 10,000 steps or something like that, you may want to just wait every 100, and you'll get kind of a better moving average of the loss. You don't necessarily need to, but you can plot it every step if you want. And this validation is the process that I mentioned of it kind of stops training, takes the weights of the model where it currently is, and applies it to that subset of images that you held off for validation. And that's kind of emulating how it would work in the real world with from novel images. And it gives you the loss of the model on those images. And so you can compare the performance of the model on the training images and the validation images. So I'll show that. I'll make sure this does it for 200 steps. I'll do it, make sure it does it 4 times. So we can look at those 2 graphs. Oh, So I just started this at batch size 4, which may make my computer, when I'm doing this this Hacky Hour, it may slow down a little. So bear with me here. But this is usually something that I run, either overnight or make sure I'm not doing a lot of other processor intensive things when I'm running training, because it can take up some processor. So this is available.
Can you pause for a couple seconds?
Sure.
A couple minutes for some questions?
Yeah, absolutely. Sure. Good time. It'll start training.
So the first one is there a prerequisite to install Jupyter to use this?
No, so this will work with Windows, Mac, Linux, and because of the way we containerize this and store this, we kind of take care of those prerequisites for you. So the prerequisites is alwaysAI, the CLI and installing that, but it's not, you don't need to install it separately and go through that process. We take care of that for you.
And can the users use a GPU to train?
Yes, so we support the use of GPU right now on our Linux version, and yeah, so you can do it through GPU through the Linux version, and I'll show you that in the CLI. So right now, if you want to use the GPU version, you should use the CLI command. That is, I don't see the option for it here in the Jupyter, but that is coming out in the next release for the Jupyter version. But right now we have it for the Linux version, and that's usually just because Linux is where we have access to the GPU. Macs right now don't really have a GPU that can be used for training coming with it, because we're using NVIDIA GPUs. They're not in Macs, and we are still working on getting access to the GPU through Windows and that containerization.
Oh, and we have another question here that says, what CUDA version is supported on Linux?
I would have to check, but I believe it's yeah, I'd have to get back into that. I think it's 10.1 maybe. Yeah, I guess I don't want to say. You could reach out and I get back to it. But there is, yeah, it can be tricky with drivers there, but I can look into that afterwards if you contact me on Discord.
I believe AB wants to say something. Sorry, Todd.
Yeah, absolutely.
Hey, AB.
Hey, hi. I think related to CUDA, I think it depends on the GPU as well, what they have, because the GPU architecture and the CUDA versions are tightly linked. Like for example, 1060, I think the one CUDA which is mostly supported is 11 or 11.1, and but with the older GPUs, but the newer GPUs, I think it can go, I think, to a higher as well. So that depends. And I think since you will be containerizing the CUDA as well, I believe so, then it depends on like which versions like you containerize as well, right? So that depends on the kind of GPU as well, what they have in their laptops or desktops. I think so, right?
Right. Yeah, and that gets slightly technical. Where I've done it, where I run GPUs is on AWS on an EC2 instance.
Yeah,
with
yeah,
a
that makes your
single.
life easier. They have
Yeah.
their own AMIs already pre-configured. So
Right.
yeah. So I have a 1060 at thing. So I think I'm learning 11.1 or 2 something. So it pretty performs decent, but it's a very old. So it's like 3-year-old system. So cannot expect much. So yeah.
Nice. And that is where, once you have the GPU, you can you have a little more flexibility in batch size, where we're going up higher, which is going to kind of smooth out, allow you to go a little faster. And I found, at least a 3 to 4 times faster when using GPU versus my MacBook here. Any other questions at this point?
No more questions. Thank you, AB.
So I can speak to this graph a little bit. So what you're going to see, and this is the kind of good sanity check to make sure that your model is progressing, that it's training, and this is kind of validation that your annotation is correct. I've had data sets where I got them from online or something like that, and instead of the format of the bounding box being x1 y2 x1 y1 x2 y2, it's like x1 y2 width height. And so when we it's not obvious just looking at those numbers, because it has the right number of numbers. It's got 4 different points there. It's not obvious that that's the format, but it will be obvious in this graph if it does not improve. So what you should expect to see is initially be right around random chance, right about 50% losses, because it's just throwing up guesses, but it doesn't have any updated weights to improve upon those guesses. But it should pretty quickly over the first 20, 40, 100 steps drop down and improve upon that. And if you don't see a curve like this to start out your training, it means there may be a problem in your data. So this graph is a good kind of sanity check. And if you're doing it through the CLI, it's just going to be numbers, but it's still, you want it to have an initial drop off. And in this graph, you can see kind of the variance. That's okay, how it's going up and down. If you do a batch size of 1, you'll see this go up and down a little more extreme, just based on the difficulty of inference of a single images, where this kind of smooths out averages across 4, and the up and down will smooth out the higher batch size you will, because it's taking the average of 8 images, 16 images instead of just 4. And then this orange line is what I was mentioning with the validation. So this is going to be, you can expect it to be a little worse than the images that you're training on, because those are the images that you're adjusting the weights on. But it should follow the general trend of downward as training goes on. And you can use this validation line as an indication of overfitting, or just an indication that maybe you're not getting any more improvement from your model. Once this really flattens out for a number of iterations through it, or it even starts to get worse, and if this gets worse for 2 or 3 validation steps in a row, it means that the model is kind of overfitting on the training data, and it's getting worse on the novel data. And so that's an indication that maybe you shouldn't train it that much. Hopefully you don't have a lot left in your session, or you could shut it down and continue from a previous version, but not put as many steps in there so that you don't overfit. But it's not something that I've experienced. With the back end of TensorFlow, there's a lot of checks and balances in place to prevent that. So once it's done, it's going to tell you that it's done. You can shut down the notebook. You're going to get some kind of scary looking warnings, but that's just because you shut down the notebook. So don't worry about that. And then when you go back to your terminal, it's going to give you the feedback that you created your model. So this is, your model's finished. It's ready to use. There's a couple different ways of adding it to a project. We've got that in documentation, how to upload that to the model. How to upload that to an app. But a simple way is just to upload it to the model catalog, which is just AI model publish, and then put in the ID and username there. And then doing that, it's gonna upload it to your private models here. I'm not going to do it. It does take a little bit of time, especially when I'm streaming a Zoom at the same time. But once it's done, you can upload it here and then pull it down into your project, like Komal showed at the beginning, and then it's good to go. I'm going to show you the command for training on CLI, and then let Lila get into what we did with this model. So it's a very similar command for the Jupyter, but it just all the configurations that we had that GUI, where we did number of steps, we did batch size, but we just got to put that in here instead of having the GUI to do it. So this is how we start out, but we're just not doing the Jupyter flag, but we need to give it the ID, and this is the same. We need to give it the number of steps. That's num steps. We need to give it a batch size. We need to put in the labels. And these are separated by space, I believe. And then the train validation ratio. And all this is documented. All this is documented on our site. And then to continue from version, and this would be I don't remember what this is, but I think it's just continue from version. And this would be this version right here. So you have, I guess, so take it a step back. To continue from version, you need the same ID as the other one. So I put this as Hacky 2, but if we really wanted to continue, we need to put Hacky demo. So you see this ID is the same here, and then the version is the same there. And then so running this will continue from, it'll start from 201 instead of starting from 1. And this works with the Jupyter Notebook command as well, except for the Jupyter Notebook command here, where all you need is the data set, you'd also need to add the ID of the model and the continue from version, and then you can continue from in the Jupyter Notebook. So, yep.
Sorry, Todd. Okay, we have a question here. Suppose I add more data and then click retrain. Will it keep the progress done so far, or retrain everything from the start?
You can add data after training and continue from a previous version. Right now, you cannot add labels. So like if you train my data set where I've got 5 P's and thumbs up, and then train that for X number of steps, then want to add your own, like, okay, or something like that, you'd have to start from the beginning. But if you wanted to add your own hand, which Live is going to go over, and change this, so this is the data set you're training on, you can change the data set that you're training on and continue from the previous version. That's okay. It'll pick up from where you left off.
Sweet. And then actually, Plamen, I think we should take this question on Discord. I'll reach out to you separately, Plamen. Okay, you can continue, Todd. Thank you.
Okay, yeah, so that's it. That's training. Oh, so what happened was, which I forgot, was when you continue from a previous version, the total number of steps that you want to put in there is going to be the total number of steps that you're training. So what I did was I continued from version 1, which I had initially trained 200 steps, but I only asked it to train 200 steps. So it said, you're done without doing anything. So remember, if you want to add, like double it, you need to do like 400 steps, and then the total is going to be 400. So that's it for training. I'd like to give Lila some time to go over the app that she built around this model that I trained.
Nice. Yes, so we have a little sample app for you guys to use if you want to do this challenge where you interact with your home using voice commands. Not that you have to use voice commands. If you get fancy with hardware, you can do that too. But the premise of this app is that let's say you have someone who wants to use Siri or Alexa or Google, but for some reason those devices don't like their voice. Maybe they don't get the volume they want. Maybe they can't enunciate properly. Maybe you want your friends to be able to turn on your Siri. And so what you can do is you can pre-record an audio message and assign specific signs to specific audio messages, and then trigger those audio messages using gestures. And that way, the individual isn't limited by their voice. You can use your hands to turn on like a prefab sort of setup. So this app is pretty simple. Feel free, if you find that you can make it better, you can submit a pull request, like fork it and submit a pull request. I would love to have it improved. So right now, pretty much what it does is it waits for a signal, and then if it receives a start signal, which is, we chose the 5 sign, and we chose that because it seemed to be more sensitive or less sensitive. Like the P sign seems to be picked up more frequently. So we wanted a less trigger happy sign, to start it. And then it waits just a little bit. If it doesn't receive another signal, it will reset. And in the meantime, it gathers kind of like a consensus of what it's seeing your hands doing. And it's like, okay, I think this is the sign. This is the audio file for that sign. I'm going to play it. So first I'm going to demo the model that Todd trained. So this was trained on his hands, and he shared it with me, which you can do through collaborators in our dashboard. So it doesn't work perfectly, but it does work pretty well. And that's why we also like this app for you guys. Todd mentioned how long he trained it for and how many images he got. So you don't have to train it, to the ends of the earth to get a reasonable working model here. But if you train it on your own hands or your own gestures longer, it will only improve. So with that, if there's no questions and stuff, I will share on my screen and get set up here. Okay, so some background. The app, can you guys see my GitHub page okay?
Yeah.
Nice. So that is where you can find the app. The link, Kamal, is posted in the chat. So what you can do, she showed you how to set up a project. You can clone this. And also in the README, you'll find that there's instructions. So pretty much what you need for this app, you need an account and you need it installed, which Kamal showed you how to do. And then you can start using Todd's data set, which is linked right here, and it's also in the chat. Excuse me. And then you can, if you just want to use Todd's hands and train Todd's model all over again, you can do that. But what we'd like you to do, and what I think you should do, is add your own versions of those gestures. And I will show you how to do that and then merge the data sets. and then run the training that he showed you to train yourself and generate your own model. And then there's a link to post-training model usage. So what you can do is you can publish it like he showed you, or you can use a local version and test it out in this app. And so you cannot use this app out of the box. It's kind of a tease. I've put it up here that you have to train your own model to use it. Otherwise, all you're going to be doing is using MobileNet, which will do nothing. So I will show you when we walk through it, but I just want to note that, so when you train your own model, you're going to publish your model or use that local version tag, and then you're going to have to change this piece of code right here to use your model. And I put alwaysAI MobileNet because that won't break anything, but I have used Todd's model and set it up locally already. So so that's that little caveat with this app. It does not work out of the box. It's supposed to be a skeleton for you guys to build off of and do your own thing. So there's instructions here for getting that data set, and then links to all the helpful tips and tricks that we put together on our docs page for data collection. And that's another reason why we kind of like this model use case, where I can collect all these images that Todd has collected, you know, thumbs up, peace, 5, sitting right here in front of my computer. I don't have to go out in the world. I don't have to do anything fancy. But if you get fancier with your stuff, you know, feel free to collect any images you want, train as you desire, and build your own fun app. But here's all the stuff that you need. And it also has some tips for making audio files. I am on a Mac, so I used QuickTime Player, but any way you can record an audio and get a message. If you have Ffmpeg, that is a very easy way to make a WAV file, which is what most Python libraries use. And I've tested simple audio on a Mac and a Windows. That works great. If you have a more versatile or better audio library, please, you know, add it in, let us know, because a lot of people always ask about that, and sometimes these change from version to version and things break, so it's always good to keep a lookout. And then the rest of it is stuff that Komal's already showed you, how to set up a project, add in that model, and then you'll be up and running. And as she said, you know, send us your GitHub URL if you want to fork this, or if you want to make your own project. We'd love to see what you do. So with that, do we have any questions on that? Or
yeah, Lila, do you think we can use our mobile phones to record the data?
I don't see why not. Yeah, I used my Mac because I was here, but I know that there is like an audio recorder thing, or that, you know, I have like saved audio files on my phone that other people have like sent me, those voice messages, so you can make a voice message. I would think that the output would be an M4A or an MP3 or something. So I'll show you the command that Ffmpeg uses. You just need to know what suffix it is and then change the command. You know, I used my Mac and I used QuickTime and I used M4A, but I don't see the problem using a smartphone to record a message. Anything to record a message, as long as you can get it on your computer and use Ffmpeg to convert it to a WAV file. Yeah, good question. Any other questions?
Nope.
Okay, cool. So let's see. I am going to bring up my terminal. This guy. Okay, you guys see that one okay?
Yeah, we can.
Okay, so so what you would do, you would git clone that URL, then AI app in local version add, or do the models add your model, AI app install. I've already installed and I don't want to have it reinstall, so that's where my app is now. And then we can do, and I have to get my phone ready. This app is, I feel like I'm like conducting an orchestra here. I have to make sure my phone is ready, and let's see. Hopefully it works. Pray to the demo gods or whatever it is you like to do. Okay, so
I'll light a candle.
Yeah. So that's the thing. You can see local. Okay, here we go. I want to keep this guy kind of visible so you can kind of see what it's doing. Keep my phone kind of up in the corner here so you can see it turn on. Okay, let's see. Hey Siri. Set a timer for 2 minutes.
Okay, 2 minutes and counting.
Hey Siri. Hey Siri. How's the weather today?
It's currently clear and 75 degrees. Expect mostly cloudy skies starting in the afternoon. Temperatures are heading down from 77 degrees to 64 tonight.
Okay, and now I need to remember to turn off my timer because I always forget and then it's going to interrupt me later. So there you go. Hopefully you guys could hear it. Sometimes, I don't know if you could, I think you could see the phone turn on, but pretty much what it does is it waits for a gesture and triggers the Hey Siri, Hey Google, Hey Alexa, or just Alexa, I guess is what it is. And then gets the next command for you and plays that. And it did work, thank goodness. Yeah, any questions on that?
Lots of comments though, no questions, but people are saying very cool and Andres is nice.
I was a little more tickled than I thought I would be when it worked. You'd think that, you know, it's nothing new. Siri does it all the time, but for some reason, I think it's really fun. Hopefully you guys have some fun with it.
Super cool.
So it did work, but let's say it hadn't worked so well. You know, like you could see like the peace sign, like it was like kind of like, oh, is it a peace sign? Oh, is it not? Or the thumbs up, like sometimes there wasn't a really strong consensus. So one thing you can do, and that we hope you will do, is generate your own images. And so like Todd said, his data set is for thumbs up, peace, and 5. So you can take your own thumbs up, peace, and 5 and easily add it to that. If you want to do other signs, you can add those labels, but you're going to need to train it from the beginning. You can't like start training from his and then add them in later. That won't work. So just kind of like bear that in mind when you're doing this stuff. But let's see, one thing you can do. The next repo we have is an old GitHub repository, and it's linked in the chat, but we've updated it. So this is the new image capture dashboard that Todd demoed a little bit earlier, and I'm going to do it again. So same thing, git clone, you make your project, you install, and then you run it. And it doesn't have any models, so you'll see a little warning sign, no models, and that's totally okay. No problems there. So let's do this guy. Again, I already have it all set up because I was testing it out and I didn't want to take it too long. But let's start it. And then, oh, wow. And you can't see this, but my Zoom is like blocking my browser window. There we go. Okay, so we'll refresh. And so now you see this new stuff, and we have this button that Todd alluded to. So we go here and there's nothing here. So like, what does it do? But now if you take a snapshot and then you go here, you'll see the snapshot and you're like, oh, that's nice. Maybe I want to take some video. And then you go here and you can see now I've got 2 things. So from here, you can look at it and be like, ah, that's gross. I don't like that anymore, and just delete it. And now it's gone. And you can see, well, maybe you can't. Now you can. Here, they're all getting collected here. And let's take a look at this. Now I can preview my video and I'll be like, well, that's pretty good. Or maybe we realize, oh, I forgot to show my hand, so I want to delete that. And now it gets deleted from the samples folder. So that cleared it out. So now we can come here. And I noticed that on Todd's model, my right hand worked pretty well, and he noticed that too, but my left hand didn't. And that was another thing with the orchestration. I had to like make sure I was using my right hand and starting it. Anyway, so I'm going to do my left hand so we can start. And like, as Todd said, you know, you can get lots of images just sitting here at your desk, and you can see data collection ended. Now we can view and try that out. There we go. And we like that. Let's say, so I'm running this on my Mac because that's easy. But one of the things we kind of brought up last week is that you want to be able to collect data on the device that will be running the model and doing the inferencing. And sometimes that's an edge device. And so it's kind of weird, you know, like how do you collect images on a Pi? You know, you can't really see them. It's strange. So now you can run this whole thing on a Pi and you'd be like, okay, that's a good video. I liked that one. It had all my hands in it. But how do I get it? And well, it wasn't last week. It was probably like a month ago. We had to secure SSH into our Pi, and then we secure copied all those files over. And you probably remember I had like a bunch of typos and it took forever and it was weird. And then what if I get all those videos over and I don't even like them? I have to do the whole thing over again. I have to deploy the app. So now what you can do is you can just download, and it downloads to your Mac. And now I have it on my Mac, easy peasy. And then if I want, I can just delete it from the Pi. And I'm going to delete it here, but it's going to delete it locally. That's fine. So now everything's in my downloads folder rather than my directory folder. But that's kind of a handy little feature. There's some other comments on that repo, some other suggestions. So I'll try and work those in if we have time and stuff, and if that seems like a good thing. But if you have any other suggestions for the image capture, you can always put them there or on Discord. Any questions on that so far?
So not on that specifically, but there is a question for Todd.
Yeah.
Todd, are you still there?
Yeah.
Okay, cool.
I'll stop sharing.
So do we support the NVIDIA GeForce 1070, for example, for model training?
Yes, I believe so. So I think the issue with the GPUs, we should support NVIDIA, but it's just locating and installing the right drivers to work with our container and kind of configuring that to be open in there. But as far as my understanding, and I will revert to some people after this to confirm, but it shouldn't be specific GPU limited to specific GPUs. It's more the drivers and the CUDA version and everything.
Okay, and then if they have questions about what drivers are needed or what configurations are required, they can just reach out to us on Discord.
Yeah, I'll work with them and probably get Steve. So I've set it up a number of times with GPU, but it's not something that I know well enough off the top of my head. I kind of have to get hands-on and see.
Okay. And AB has offered some suggestions too. He says the host needs to have the drivers in CUDA configured and it should work out of the box. So just kind of like what you said. So thanks, AB. And then we have a question here that says, how difficult is it to move the gesture recognition demo from the Mac to the Raspberry Pi? What frame rate does it run on the Raspberry Pi?
That's a good question, and I have not tested it out yet. I can do that right after this and find out. This week was kind of a blur. I'm glad that I got it tested on Mac and Windows at least. Yeah, I think, I've run other apps. I've run the sample, the image capture one on the Pi, and the frame rate, I think that one was set to 25 and it seemed to be just fine. That's a good question. I'm not 100% sure. You can continue it on Discord and we can see. It's a good point. Macs are pretty fast. It might be a little too slow, and maybe you can tinker with the app to add some buffer or maybe some other logic. I can step through the logic in a minute if we have time with the gesture app, and you can kind of maybe see some points where you could compensate for that frame rate with some programming logic.
Yeah, and AB said that if MobileNet SSD model works on the NCS2, then it should be pretty good frames per second for that.
That's a good point. Yeah. Yeah. Thanks, AB. AB.
Okay, and to the earlier point of the question, is it difficult to move the gesture recognition demo from Mac to Raspberry Pi?
That should just be a deploy. I need to double check that the library will work on Linux. Mac and Linux are usually pretty compatible with that kind of stuff, but because it is a separate Python audio library, I don't want to promise that it will work perfectly. I'll have to test that out myself. And then, we've had this problem before with certain dependencies, like we don't want to put up a repo that, you have to tinker with the requirements, like uncomment, comment. So maybe if it doesn't work perfectly, I'll just make a new one that's supposed to be deployed on a Raspberry Pi. And then, there's the caveat, what about jets and nanos? What about this and that? So usually most of our stuff is very easy to move from device to device, but occasionally if you're using an external library that just won't be compatible with a certain operating system, that's the only caveat. If it's just not compiled for an edge device, then it gets a little trickier. But yeah, good question.
Yeah, are you referring to a specific library?
Oh, like the simple audio Python library? There are some Python libraries and stuff that just won't work. And I've had some problems with audio libraries in the past, and now Simple Audio is working for Mac and Windows. So I don't think it'd be a problem. I just don't want to promise and then disappoint people that it wouldn't work.
Right. Okay.
Yeah.
And then, sorry guys, it's like, and I think AB wants to say something. Hey, AB.
Hello, can you hear me okay?
Yeah.
Okay, so I think that's a very good point that sometimes the audio libraries give a big problem. I've been into that trap earlier to write a generic code. So I think the best way to go about that is you can use popen and all that kind of stuff using to open console VLC. So this code will work across the platforms because that's a POSIX call. And you all the VLC all the VLC code, the command line arguments work in. You can do all the pause and all that through sockets as well. So I have a sample code. I can share it with you. I've used it multiple times. There's the Halloween Killer app, which is there in that it uses as well. The same CVLC. You can just take it from there as well. And that is a very quick code, but I have a better code as well, which has all the endpoints. We can pause and do all sort of good things as well. So if you want, I can give it to you. That's fine.
Yeah, definitely. Yeah, if you.
Because that way you can run the same app on Windows, Linux, anything. So it works
Yeah,
fine. Just you
definitely.
need to install the.
Yeah,
you
especially
need
for
to
a
have
more
VLC
robust
installed.
solution. Yeah, this one was a little quick and dirty, but yeah, if you want, especially if you want to put it on Discord, even for other people, if they're doing this gesture recognition app and they want to use audio files rather than some other solution, that would be really excellent.
Yeah, I'll try to write a small module for that, and then I think it will be easy for people to just import it then.
Very cool. Definitely.
Sweet. Thanks, AB. AB to the rescue. Every
time.
AB
to the rescue twice. So we're running kind of short on time. I do want to show you guys one more thing. That was what Todd mentioned, to merge your data sets. I'm going to get rid of that because that looks silly. So I downloaded Todd's data set. Let's say I just took that video that I took with my thumbs and I annotated it in CVAT and then exported it as he showed you. So here you can see is that hands-free zip, which you can download in the chat or on that GitHub. There's those links. And then this is my annotation. If we want to merge them, all you have to do is that. And then, so it will work really well, and this will take a while because they're kind of big. It will work really well if you have exported it from CVAT. If you open them and you're trying to compress them, you just need to remember to select the annotations and the JPEG images, the lower level directories, and then compress those. You don't want to compress the upper folder. You'll get some errors. But as you can see, it merged them. And now you can see there's the merge data set. And so what you would do is, and then you would say merge data set, and then all your other commands. Or you can rename it if you want. But that way you're using the new data set with your hands. I mean, we're kind of over time. So I was going to walk you through the code, but I will just really quickly tell you that, let's see, just point out the different files that you're going to be working with. This is your main app.py. It just it's everything that Todd showed you last week, where it gets the hand image and then passes it to the signal detector, which is the hand, the specific gesture model. And I showed you on GitHub that that's the model you're going to want to change to your model. So all it does, you change the model here, then it passes the detection from the hand model to that model, if it gets something back, this is where the magic happens. If it gets something back, it passes it to this instance of a class that then does all the logic. There's some timers, like as soon as it gets the start signal, it starts a timer. Then you have a 4 or 5 second window to get a new action. And so what it does is it already listening? Has the timer, has the start signal been received? Has the timer expired? And if both of those are true, then it will go and try and get an action. And then it just looks up here for your kind of like, you know, pairing of sign and audio file. So all you have to do is put in your audio file and your sign, and then you could tinker with the logic, you know, maybe increase the time or add some buffers. And pretty much in the meantime, when it gets the start signal to when it makes a decision, it's just gathering all the labels that you send it from that app.py file, and then it gets the majority. So it gets the most common, sums them all up, and then says, okay, is this over a threshold that I've set, which is right now 50%. So if there's a label that was seen more than half the time, say, okay, I think you meant peace sign, and that means I need to play this audio file. So that was my logic, and you're welcome to outdo me for sure. And then the one last thing that I wanted to show you is this very simple command, so you see I have these timer and timer.wave and other audio files. So the command is ffmpeg, I means in place, and then you do old file dot, and mine was m4a, but it could be anything. And then the new file is like timer dot wave. So, and as I said, I just used QuickTime Player. You could use anything you want. As soon as you have this file, whatever it is, you just need to give it that, and use this command. And you do need to install ffmpeg, but we have links on our docs. All those links I gave you there, and in the README, there's links to ffmpeg. You just have to install it. It's very simple. And it's really useful. It's not like this is the only project you're going to use it for. It, you know, you use it for annotation. It's really handy with renaming things, splitting up video files. So that's it. We can dig more into the app if people want, or if you had any other questions, but I just didn't want to keep you guys here forever. Seem okay?
Hello, sorry, my computer just froze for a second. Yeah, so any questions on what Lila just shared? Okay, while the questions are coming through, I'm just gonna take this time to really quickly announce our model training challenge. So if you are interested in coming to Hacky Hour and speaking, or maybe getting shout outs on LinkedIn, or being featured on our blog post, definitely outdo Lila. That's the challenge. You have to outdo Lila. Train your own gesture model, use your own signs, and build your application using our model training toolkit. And make sure to tag us on LinkedIn, Twitter, Facebook. We're on all of the above. And as always, we're here to support you through the challenge. If you have any questions at any point, feel free to ask via Discord, and I'll make sure to add the link in as well. I think unfortunately I have to stop sharing to see this question. Yeah, and AB's suggestion is you can create cool GIFs with ffmpeg, so always to the rescue. Thank you, AB. And I believe there's no more questions, so definitely participate in the challenge. Definitely tag us. If you have any questions about the challenge, you can reach out to me directly. And I'm going to list my email on here as well. And we'll see you next Thursday. We do this every Thursday at 2 p.m. So this is your chance to join us, ask questions, pick our brains about anything computer vision related, or always AI related. We're here to help you out. So with that, I'm going to adjourn this Hacky Hour. Thank you, Lila, and thank you, Todd, for a great demo. And we'll see everyone next week.